And so we find ourselves here again, once again, at the computer with our Love2D tutorial project open, and we find ourselves thinking, what shall we do next? What we're going to do next is something that needs to be done before the next thing can be done. Does that make sense? Of course not. To that I punch. What we're going to do is we're going to make our character jump. And that's going to involve some modifications to our animation module. And this we'll be doing today. So, first, let's go and check out player. As I said, we want him to jump. We want him to play a jump. And you can see right here we have this commented out where we were going to do the jump. So I'm going to put it back in. And instead of up, I'm going to say key down is Z. And we probably don't want to be punching when we jump, so we could say and let's go over here and look at the files here. State machine, and it's just the state name. So we want that state name. We want to compare that state name, and we want to say, and that state name is not equal to punch. So if he's punching, we're not going to jump. But if he's not punching, we can jump. Now we need to create a couple of functions for him to jump. So we'll just grab the punch ones there, and we copied those. And I'm going to do this. Very simple. We're not going to stop anything there. And when the animation is finished, we'll go back to idle. Let's see what happens with that. So I'm going to push Z. Yeah, it's not happening. Well, then the question becomes, what have we done? Let's take this out, just to make sure that our little change is working. It is not working. Very interesting, ladies and gentlemen. Very interesting. Let's try this. See what happens when we do this. Nothing. Okay. I'm going to go back to Z. Now, have we... Yes. Oh, did we need to... I'm trying to remember. Did we... It's been a while since I've looked at the state machine. Were there any requirements? I don't think there were. Let's see. State machine. Yeah, I think we're good there. Did I mess something up here? Animation finished. Animate jump. Changed idle. That looks okay. Let's go back and check the player, and we'll see that we do have jump. Is jump, so our animation is in there, which is good. But what is he doing? Let's do a little print just to make sure we're getting in here. Not a print, a print. Print. Hi there. I always like to be nice to myself whenever I'm debugging. Debug mode enabled, and let's run that. And I'll drag the window over here. We'll press Z, 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 Z. Yeah, that would be one of the reasons why we're not getting anything there. So why is that? Maybe I should make that another if statement. Let's check this. I'm going to take that out again. We'll figure this out really quickly. It's still not doing it. Just take my word for it. Let's go for this. And we'll end this. And let's see what that does. Will he jump? He still is not Oh, of course, we're in walk. How silly of me. You're probably yelling at the screen. You've probably been yelling at the screen the whole time. And that's okay, because I would have been yelling at the screen also. We want to do this... really, we want to do this in jump also. So let's check this out. We'll make sure that it works. We'll move and jump. And it's not working. Not working. We can punch. But we cannot jump. Reload that. As long as we're walking. Still nothing. Okay. Let's take this chunk of code to the idle state right here. And we'll put it right here. Yes. Let's see what... And actually, we don't have to do this because we're in this state. So if we're idle, we can jump. And also, if we're walking, we're not punching. Right? So we don't need those. Sorry about that. And let's come up here and idle. And let's print something out. Which, yeah, see, we're getting it. Hi. But he's not changing. So animate, jump. And then we go into, let's go ahead and ensure that we're going into here, jump. And we'll grab this and we'll say jump, enter. This is called print debugging. So much fun. So much fun. I'll bring over the window. Okay, so we're not changing. I've probably forgotten that I'm supposed to do something here. Forgive me, forgive my stupidity, you will. So we are trying to change. Oh, there it is. My fault, people. And also in the walk, it's not a dot. We need that colon so that we can have that implicit self passed in. Otherwise, it doesn't know what's going on. So jump. There it is. And we must have said... Let's do this. Let's print finished right here because we have an issue here. That's yeah. See, we're not getting a finished. So let's go check this jump out. Jump. So we have animation. Let's go check our animation and we'll look and see what we're supposed to have. Loop. So how many? It's 1, 2, 3, 4, 5, 6. So we don't want to loop 1, 2, 3, 4, 5, 6, 7, and we say false. It wasn't looping anyway. I'm not sure what's going on here. So it looks to me like he's actually getting to the last frame, which we said was... It's just one frame. So it's just one frame. Let me open that in my graphic editor of choice, which would be paint.net, at least at this point. Image types, where are we? No, we're not in lib, we're in... Let's graphics. And I'll zoom in so that we can see him much better. Muchos better. Here we are. So we had one frame, which is here. So we should be done with that animation. So there must be something a little broken with our... Since we said false, there's something broken with our animation class, I believe. So we say column size is this size loop playthrough once. So if we say, so if frames is less than or equal to 1, then return. So we shouldn't do that. If frames is less than or equal to 1, then we should say, right, self.done is true. And then return, because we're done. Let's see what that gives us. We should jump immediately and then go back. Yeah, that's what we want. That is actually true. So there was a bug there. You see, if we only had one frame of animation, we never were saying that we were finished. But now we're done. We're finished. Finished, I tell you, we're finished. And we must have been, yes, we were. We were saying in our player state machine, we were saying animation finished, which is... Where did we do that? Is that a... Oh, it's in the sprite. So the sprite class, the sprite module checks there's an animation finished here, and was probably just checking that. Yeah, see? If this current animation is nil, or not equal to nil, then we'll return that. Otherwise, it's true because there is no animation, so the animation is done. Okay, so that works. So we fixed a bug. I love fixing bugs. It makes me feel better. It also makes me feel really bad because that bug has existed for how many episodes? 35? Something like that? And we never saw it. Actually, I never saw it. You probably did. Maybe you did. But, at least it is fixed now. So then the question becomes, so we're finished. So what we really need is to play that. The question is, how are we going to do this? Because we're calling this the animation state machine in player. So we probably don't want to do that. Let's do this. Let's make a local. We'll call it jumping. And we'll set it equal to false. And we'll say here, jump enter, we'll say jumping equals true. And if jumping, we'll say if not jumping. So this, when we jump now, we should get that, which is what we want. So we're going to control his jumping ourselves. And we'll do that. I think we'll do that here. And we may we'll have something we would call a local call it what we want to do is save his Y position before a jump, because at this point we're not going to be doing any kind of really complicated jumping things. Just whenever he jumps from a level, he'll return to that level. So we'll say last Y, or let's say Y before jump, and we'll just set it equal to, let's not set it equal to anything. So there's a number of ways we could handle this, and right now I have the jump enabled in the walk and whatnot. Let's do this. We can do this. So let's say if jumping and Y before jump equals nil, then Y before jump equals self dot right dot position dot Y. So we're going to save that Y position. So that's only going to happen once, because now Y before jump is not going to be nil anymore. But let's also come up here. Let's put this with the state for now. So we'll add this here. We're going to do this. So if not jumping, then Y before jump equals nil, so that we can do a check. So that's basically our little flag, as well as where he was before he started jumping. Yes. So then we'll say else if jumping, then this is going to equal this plus, we need a jump speed. So for now, let's go with 100. We'll change this. Times delta time. And then we're going to need a deceleration. So I know I can do this differently, but let's just we're sort of improvising, if you will. Acceleration. Let's just let's do y acceleration, and let's say 100, just for now. So we'll say plus. Let's add this here, and then we need. Actually, let's call it y gravity. Yes, I like that better. And let's do, just to try it out, let's do minus 50. So we'll have our speed, our initial velocity. I'll go ahead and end this. Let's do y velocity here, and it's going to be 0 for here. So we'll hold on to this. So if jumping, then let's set y velocity. Wait, we should set y velocity here at the beginning. Y velocity, let's say, is 150. And then here we'll say y velocity equals y velocity. So with acceleration, you add that to your velocity to change it. And since that acceleration is per second squared, we'll multiply it by dt to get per second, so that we'll have the velocity that we will decrease or increase our regular velocity by. Hopefully that makes sense. And then we'll say y velocity. And then we can say if self.sprite.position.y is less than or equal to that last, what did we call it? To go back up here. Y before jump. So if it's, actually it would be greater than, wouldn't it? And this should be 50 because our screen goes from 0, 0 in the top corner. Y is positive going down, I believe, if I remember right. So if that is greater than y before jump, then jumping equals false. See what we're doing? And we'll say self.position.y equals y before jump. And let's actually do that this way. Actually, yeah, that's fine. And all right, let's try this out. It's probably not going to work. Let's try it. Jump. I may have, let's do a print here. Who would have thought it would be so difficult to get somebody to jump, huh? Some little fella to jump. Well, we're using no framework at all, and we're just having a blast, right? Jumping, 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 jumping. Let's print. Let's put our y velocity here and see what it looks like. Drag that window over. Wish there was a way not to have to drag that over. So he's going, and he's not. He's actually not moving at all. Interesting. We have a self.vx, don't we? Do we have a self.vy? Just out of curiosity. We don't. Okay, that's good. That's fine. Let's get rid of this up and down, since we're not going to mess with that. Let's print this after we've done that and see what's going on here. Jump. Interesting. I'm probably doing it wrong. I'm probably yelling at the screen. Stop! Say 100 here. I'll figure it out. I promise. I promise I'll figure it out. Why aren't we moving our little fella? It must be that we are in test somewhere telling our little fella here, the player. There he is. Yeah, right here. That's only if he collides, though. We're not setting it anywhere else, and that's fine. That should be fine. Let's do this. Just to see that we are actually able to move this little fella. So that should move us down or in a direction. Yeah, it's not. Well, that's strange because this may have something to do with some of the things that we did earlier or last episode. We can move up and down this way. That's really weird. If I go down, so that would be plus. We go here. Let's just say move him all the time. Should move down, and he does. So what? Self.sprite.position.y equals self.sprite.position.y plus, let's say 115. See what happens when he jumps. Okay. So really we want to, I think we want a negative number for the y velocity anyway to make him move upward. And let's comment this out. We're not really there. He jumped up. And then he comes back down. So I was looking at the screen. Sorry, you didn't see it, but I'll show it to you here in a second. I'm going to change that number. So I'm going to walk him and then jump. And you see how weak that is. And then boom. He should be done here. Say greater than or equal to. And then jump is false. So then that should change us back. Yeah, jump or jumping. Oh, that's my problem. Sorry, people. Okay. This gravity needs to be more. Let's do 250. Let's say 250. Let's see how high it jumps then. I want him to come down faster than that. So let's do 500. And let's say y velocity here is minus 250. We want him to move faster down. See, I like that. Oh, that feels good. But it still needs more deceleration. How about that? He's not jumping as high though. 1,000. Let's do 400. Punch. And he's still moving there. So when he hits the ground here is x velocity. Should be 0. Yep. Alright, see. This will change. So when he hits the ground, he should definitely, let's see, let's try this. Yeah, that works. So he's actually jumping. Can he punch in the air? We kind of need him to punch in the air. I'm gonna get rid of this print. And yeah. So he's jumping. We should still, even when he's jumping, be able to punch. So let's grab this. And we'll put this here. Matter of fact, let's grab this also, because if we're going to do this, we basically need to set this to nil down here whenever he's done jumping. And so if he's finished, and actually really we can control this whole thing in our update instead, really, and that may be what we just need to do. And maybe there's not even a jump, maybe there's just a plain old jump enter. And then we can say, hey, if he punches, he can totally punch in the air. It's no big deal. Yeah. Let's remove this and see what happens if I'm still thinking. There, he's jumped, and that's because we had it like this. Yep. Okay, we were down here somewhere. Where was it saying? 31. Oh, that's why. Sorry. So let's just we probably want to be able to check for jump, but really this is going to let us check for jump. So we probably really just don't even need that. That way we can control all that stuff. See, he should still return to idle. So we should probably do the following down here. And perhaps hopefully, my madness will make sense in a minute, hopefully. Jump, and then he's, okay. All right, that looks, see, he wasn't on the ground there. He was on top of that sprite. It's strange. All right. I don't think that's going to affect what I plan for us to do here. So we've got him jumping. Now we need him to be able to punch. You know what? I think I will just leave this in here for now, because this is, I don't know, it feels more explicit this way. So we can say, yeah, we can get rid of this. Get rid of that, I think. Except that we're going to want to be in the air. Yeah, we'll leave these. And then if he's jumping, so we can say, where is it? Here. And we won't say VX is 0 this time either. Yeah, baby. We'll get rid of this, and we'll give this a try. Jump, punch. Yeah, I think that's okay. Jump, punch. Jump, punch. We'll jump. I like it. I really like that. So, except for when he's on top of something, which, you know, that would be pretty cool if we could, let's get rid of this. We're not going to move up and down at this point. That would be really cool if we could, here in test. So here's our player, rect1. The separation is the closest point on the bound. Let's print that separation. Print Sep. I don't remember exactly what that was. I'm thinking about having him, if he comes into contact with something on the bottom, it's a table. Okay. So then we need to go in. It's probably a rect, I would imagine. Where is that stuff? The Manowski difference. Did we put it in here? We did not. We had a special MD. R2. So we're in the rectangle. So we had a rect. There we are. So Manowski difference was where are you? Yeah. So we want to create a centered rectangle at the new left, a new side. So then we would want. Okay. So we're looking at the. Let's look at the max or the bottom basically. So we want that Y, that bottom Y. I want to see what that looks like. So let's print sep max. Basically, we're looking to see if that collision point is on the bottom down here. Then we'll stop his jumping. And apparently didn't do that right. So we'll go back to the rectangle. They create centered, which is here. We are returning a rectangle. So what's the problem with max? We could find it. We should be able to use this function here. Closest point on bounds. Oh, we're returning a bounds point, which is a vector 2. Yes? Yeah, so let's look at sep.y. Sorry, I thought it was a rectangle. I'm crazy, aren't I? Okay. So this is what I got. So if we go, we're not colliding there. So the closest point on bounds at this point would probably be, actually let's print sep.x, and then we'll print, let's print them both together. Check and see what that does. Jump. Yeah, 0x is fine. But see, we're getting kind of strange. What I want to do is, if it's on the bottom, but what's weird is this number is moving. X, self.x and point.y. Point. XY, XY. Okay. XY. So that Y is, for some reason, moving. Let's check this. Let's go back there. Closest point on bounds. Finish checking x-axis. Move to the y-axis. Really, you want to know if it's been hit from the top or the bottom. So there's your point. Closest point on the bounds. If max x minus point x is less than min distance, let's look at this here. Let's say print, we're going to figure out which one this is without actually figuring it out. If I collide with the bottom, you should get one of these. And if I collide with the top, we should get one of the others. Let's just check out and see if this works. So here, and I'm getting Y2. So time here. Something else let's do is... yeah, that's fine. Let's leave this. Let's come back in here. And I want to... Let's undo this, and I want to go up and down so I can do some collision testing. Let's come on here and go up, and I'm getting Y1, so that's perfect. Okay, see that? Then if I come around here, I'll get Y2. So Y2 would be colliding on the bottom. So we are going to, let's see. So Y2 is bottom. And this is top. So if the y-axis, yeah, and well, let's also check this. What we want is something to return and tell us we've collided on the top, the bottom, the left, or the right. So if we do this, we get neither one. Interesting. And if let's see, let's jump over him real quick. And I get, see, you're not seeing this. I'm getting nothing here. But if I do this, I'm getting an x value, a positive x value, which basically says this is the separation vector, which says move him out this way in relation to whatever he's colliding with, right? So that makes sense. So that would be, so if the x value is positive, then that's going to be to the right. So I'm going to just put this believe that's how that's working, because remember, we're getting right here. Yeah, see, that's a rectangle. Sorry about this, but we need to figure it out, you know. That's in test once again, closest point on bounds. So then we're using that as the separation vector, really. That's going to be our separation vector. So our separation vector, the closest point on bounds, returns a vector 2 that indicates the closest point on the rectangle's boundary, or the point, let's say, the point on the rectangle's boundary that is closest to the given point. Hopefully that makes sense. Right, so, and then we'll go back once again here. So that separation is indeed, that's going to be our separation vector. So this will give us our separation vector. So a positive x equals left side collision. Or let's do this. X greater than 0, x less than 0 equals right side collision. So the same for y. Y is greater than 0 equals top side collision. Y is less than 0 equals a bottom collision. You see, because our separation vector will point a certain direction. Let's see if I can explain this. I'm thinking about it myself here in my head. Rectangle. So we have our axis aligned bounding box. Say we have a point inside of that rectangle that, say it occurs here. Say that's our collision point. Well, that means that this other rectangle that we are checking, it's colliding there. Because remember, this Minkowski stuff is kind of weird. But anyway, so the closest point is going to be directly across from this, of course. It's going to be this guy. And this direction, since we are focused on the 0, 0, the closest point on the bounds, and we give it a 0, 0, because remember, that's sort of where our origin is when we're doing this Minkowski stuff. So then we can get a direction if it's this way. So we have the negative x, and then y is 0. So that's going to be the left side, or the left side. Did I do that? Did I say that right? I'm sorry. That's going to be a positive x, because I guess it's going to be pointing this way. So that's going to be a positive x. Anyway, don't save. Let's put another function in here. And actually, I don't think it belongs here. Let's put it in the utils class. So we'll say bounds point to collision. Side. And we'll take in that bounds point. Bounds point. So we'll say, given a bounds point obtained from rect dot closest point on bounds, this function returns an object that indicates where, if any, sides were involved in the collision. So we're going to say local. And so we'll say, we'll just make it real nice and say collision info equals a new table. So this is going to be a table. And we'll return collision info. And we'll say, we'll just go ahead and before this is saved. Go back here. So we know that we've collided. So then the closest point on the bounds is going to be some sort of, it's going to be something. So what we need to do is, and we're running long, people, collision. So we need to say if, we're just going to do this real quick. We'll probably pick it up later. If bounds point dot x is greater than 0, then I'm going to go ahead and just say this, collided equals true. I'm going to add an element into the table, even though when you... yeah, I'm just going to add this so we can check that to see if there was a collision. And if there wasn't, then that'll be false. And we'll just say so if bounds point x is greater than 0, then collision info dot left equals true. See what I'm doing? Else if bounds point dot x is less than 0, then collision info dot right equals true. And then really don't like the way this is. I don't like the way this is working out, to be honest. So we want that. We're going to have to set that every time. I don't like it. But anyway, we're doing it. So we'll end this. And then we also want to check so that bounds point of y. So if y is greater than 0, then info.top, I believe. And if y is less than 0, then bottom. Right, bottom. See? Collided is true. Let's check this out. Bounds point to collision side. Okay. So, we go right here. So let's call that local collision equals bounds point to collision side, and we'll get that, and then we'll print. Really need a table print, don't I? Let's print collision dot. Let's print collision dot bottom because that's the one we're interested in right now. And then we'll fix it up next episode. Here we are. We're jumping, and we got, and we did get it, and we have an error. So 43. Oh, of course. Yes. Do this. Forgot to add that little addition. Let's jump, and we get bottom. True. So, let me go and clean this a little bit here. Got top and bottom. So that's back to the way it is. So next time we will take this new collision info that we have based on which side we've collided on, and we will use it to stop his jump, and we will we'll check these other ones and make sure they work too next time. And until then, see you later.